Alrighty, folks. Happy Wednesday afternoon or evening to you, or perhaps Thursday morning. Hey, it's Lawrence back with you for the second of our Juniper Open Learning JNCIA Cloud sessions. I'm going through all the material from the Cloud Fundamentals course, and I'll turn it over to Gordon in just a moment, and he's also joined by Mark, who will be helping out answering a lot of the questions. But just real quick, I wanted to mention one thing specific to accessing the course materials through this to Juno's Genius. And there's a good discussion going on right now about likes and dislikes of Juno's Genius. But I just want to let folks know you will have access to that material for about 90 days. It'll run to roughly the same time as the expiration date of the voucher that you will receive. Assuming that you do the two things you need to do to earn that voucher, which is spend at least 5 hours working on the materials, and that's just a minimum, mind you. Realistically, you should probably spend more, 15 to 20, kind of making sure you understand it. But do the 5 hours and try that practice test at least one time. But you will have access to those materials even though our last session is next week. You'll continue to have access. I do recommend, of course, that you make sure you try and get through them at least one pass by the end of next week so that you can continue to ask good questions of Gordon and Mark. So feel free to go through them all between now and the end of next Wednesday, but don't feel as though you're done, right? You'll still continue to have access to that information for another period of almost 3 months. So that's really the one thing I wanted to mention. At this point, I will go ahead and turn it over to Mr. Mosley, who can walk you through today's topics.
Hey everybody, welcome back. Thanks for coming back for our second edition of the JNCI Cloud Content Review Sessions. There's really 3 modules that we're going to go over this week, and they're chapters 5, or modules 5, 6, and 7. And the cool thing about these modules is they aren't as much or as long as the modules we had to go through yesterday at such a rapid pace. And we don't have as much of an introduction to go through today, so it's a little bit more of a relaxed pace. And that'll give you plenty of time to interact with Mark and Lawrence and I in the chat window and ask some questions. Questions about maybe you got a chance to review some of the content we reviewed last week, or you have questions about the 3 modules we're going to go through today. Just take advantage of the chat window and please interact so we can make this a very valuable experience for you. We're going to start with chapter 5, and this deals with network function virtualization. Right? So we're going to talk about the network function virtualization architecture and a standards group that's kind of worked to define this architecture. We'll talk about the NFV components and some examples of virtualized network functions and how they can be instantiated and function inside of a cloud environment. So what is NFV, Network Function Virtualization? I'm sorry, it's hard for me to say. There's a lot of syllables in those, and I'm kind of tired. So think about functions on a network, right? You have traffic flowing around a network. What are some things you like to do to that traffic, right? You might want to control the flow of the traffic, like with a firewall, specify what traffic's allowed to flow. You might want to do some natting on that traffic. You might want to do some load balancing, some intrusion detection, some WAN acceleration. There's a lot of functions you can do on traffic as it flies around inside your cloud network, and we've always done these things, or at least for decades now. But it's traditionally been done on physical appliances, right? We have a load balancing appliance. We have a firewall appliance. We have a WAN acceleration. This has always been done kind of on chassis with proprietary software on them, right? Or maybe, you can add a special service card into a component you already have, like a switch or a router, that adds, additional functionality to your networking platform. So that's what network functions are, things you do to traffic. And a lot of times these network functions may be performed on customer premise equipment devices. So think about your house or your apartment, wherever you're living at, you've got some type of internet connection. So, hey, I just moved in, I've got a new apartment here, I want to sign up for internet service. And You call up your local cable company, your internet company, and you say, hey, I want this kind of service. I looked at your website. I want to sign up, or however you do it. And okay, great. Today is I lost my days. Today's Wednesday. We can get a truck out there and send a tech. Now it's going to be 14 business days before we can get somebody out there. Are you okay with that? Will you be home between 8 and 11? And it's a big wait and it's slow, right? And then they're going to bring out some appliance and plug it into their network and set it up so I can connect to it too, and that's my internet connection. And then, somebody's got to configure that. That's a slow process, and that doesn't really work very well. So we want to kind of change the way some of these network functions are performed. That customer premise equipment device, that DSL modem or that cable modem at your apartment, it does firewalling. It's a WAN, termination point. It can do some NATing for you. But it's on the appliance. It's kind of hard bolted into that thing. Not very flexible. So we'd like to change this model. All these network functions, if we can get them off of these appliances, off of this purpose-built ASIC-driven hardware, and get those same levels of functionality into a virtual machine environment, then hey, this changes the game here, because that means I can spin these services up in my cloud environment on demand in a scalable fashion and sell these services in a much quicker time to market. That's what this is all about. We want to virtualize this stuff, just like we did with the server workloads. We want to be able to virtualize these network workloads, these network functions that we've always performed on traffic. So as customers, I need WAN service, I need NATing, I need IPsec firewall. I can dynamically spin up these network functions in virtual machines, either on I can push this down. That customer premise equipment device, we're going to change this architecture completely. It's just going to be a standard x86 platform running some version of Linux with the KVM hypervisor. So I, as the service provider, can drop ship that to you overnight. You plug it in, and I'll push down whatever service VMs you need and spawn them dynamically. Or I can make that a dumb device and spin those same service VMs up in the service provider cloud, and we can give you the services on my end of the wire. It's very flexible in this, in this new cloud-based architecture, right? And that's what we're pushing for. Let's get these functions set up in virtual machines. So we're going to move from the traditional data center architecture that really isn't used that much anymore. The traditional, where we've got to get traffic routed. If we want to do any of these functions, the traffic actually has to leave the servers and platforms and be routed in a special way to pass through the firewalls and the load balancers and the WAN accelerators, right? Traffic doesn't flow that way in a cloud environment. I'm spinning up two virtual machines that actually are on the same physical host, and then the traffic's not even going to leave the host. How am I going to forward it through a firewall? I can if I spin it up a virtual firewall that does NATing and IPsec and an acceleration for me. So it just makes it work. I can offer these services in my cloud environment if I can virtualize these functions, get them running in VM. So it's a whole new model, right? So let's look at some architecture. Let's look at, there's a standards group called the European Telecommunication Standards Institute, and these are the folks that make the standards over there for things like television and radio and telephones and networking. And they've kind of been tasked with tackling this problem. How can we get these network functions that have traditionally run on these appliances unbolted from them, port it into a virtual machine environment so we can dynamically spawn these network functions and offer them in cloud environments, right? And so a lot of service providers have kind of signed on to this, and these guys have developed an architecture for how we can make this work, right? And so just trying to standardize the way this can happen. Okay. And so they've developed this framework, and we're going to take a look at this framework in the next few slides, but it kind of defines how this can happen. How can we take these network functions, virtualize them, separate them from the hardware appliances they've traditionally been offered on, and provide these in a scalable, dynamically provisioned fashion in our cloud environments, right? We want to automate this. It's got to be dynamic. I don't want to have to rebolt traffic into appliances anymore, right? So this is the framework that these ETSI folks have kind of started, right? Built. And again, from the Department of Redundancy Department, we're simply trying to get away, from the having to have some type of appliance to perform some specific function. Let's just separate those software components from the actual appliance and get them to run in a VM environment where in my already existing underlay network with my compute and storage, I can run these things on standard x86 cloud infrastructure, right? That's what I want to do. Just like I've been doing my server workloads for years. Okay? So thank you ETSI and all the internet service providers and that have kind of teamed together. And so just a couple of definitions here just to make sure you don't get confused, right? So our goal is network function virtualization. This is the decoupling of the functions from the appliance, right? I want to get this up in a cloud environment. I want to virtualize these functions. And then the virtual network functions themselves are the things you do to the traffic, like IPsec or firewall it or NAT it. These are the virtual network functions that we're actually going to perform, right, in this NFV infrastructure. Okay, so just make sure you know the difference between those kind of two things there, right? Okay, the function virtualization is how do we do this, and the virtual network functions are what are we actually virtualizing here. Okay. So here's the kind of a high-level view of the framework. Now, again, when we talked about clouds, we did this last week, and we talked about, hey, there's a couple components here, right? We talked about our underlay network. That's still here. We still have, let me see if I can get this to work. I'm not very good at some of these arrows, but, I still have my physical host, my compute, my underlay network, my storage, my switches, this is my underlay network, right, that we always have. And then I virtualize that with some type of hypervisor functionality, and then I spin up my virtual machines. And then those virtual machines, of course, run the virtual network functions. This is the firewall application or the NAT application or the WAN acceleration application. And then all of this stuff is orchestrated, right? It's dynamically deployed. This is a cloud environment. This is what we're trying to do, is offer these services. I just need to be able to get those virtual network functions able to run on standard x86 compatible hardware, as opposed to needing ASICs driven proprietary appliances environments to run in. So this is how we're going to do it. We're going to do this in a cloud, dynamically spin up the correct virtual machines to provide whatever virtual network functions we're trying to offer our customers. And it's all got to be automated, just as everything in a cloud environment is, right? So, kind of a bigger picture how this might work. A customer's going to say, I'm a customer of cloudnormus.com here, and we have some applications running there, and there are some additional functions, network functions. We need a firewall, we need and then we need a firewall to do some NATing and some IPsecing for us, and we also need a load balancer, right? So they're going to go to some type of portal, web portal, an OSS, operational support system or business support system, some type of application where they can say, hey, I want these services for these applications in this cloud. And they're going to submit that. And that OSS BSS system is going to forward this checklist of network requirements from the customer, and it's going to pass it over to some type of orchestration system. And we're going to see that orchestration system more detailed in the next chapter. We're going to talk about an orchestration system called OpenStack. And the OpenStack orchestrator is what dynamically in a cloud environment spins up the compute and the network and the storage resources. And in this case, the compute resources we're going to spin up are going to be virtual machines that are running applications that provide whatever virtual network functions the client asked for, right? And you'll have these different flavors of these virtual machines, they call them. Here's a flavor that's a virtual SRX firewall that's configured to do NAT and firewalling, right? And here's another flavor of virtual SRX you can spin up that does IPsec tunnels or acts as a BGP route reflector, right? Does deep inspection of my traffic, does advanced routing. So you'll have these different flavors that can be selected and spun up by your orchestrator, right? And that's kind of what this is all about. And so based on just dynamic client requests, we can dynamically insert network functions into client workloads, right? And it's all orchestrated and all automated. And that's the goal. So what's so great about this? Look, this is what I need to do. It's just so much faster. It's so much easier. Once I get this working, I can literally push a button and have this dynamically be in place. No recabling, no configuring proprietary appliances. It's very easy for customers to try new services. Hey, have you tried our load? We've got a new load balance offering. I'd love for you to check it out. I'll tell you what, just try it. We've got a 30-day trial. All you have to do is spin it up in our cloud. It'll load balance traffic going to all your servers, and we can try it out in your dev environment. How about that? So it's just a lot more flexible, right? And I don't need really. My OpEx isn't going to change at all because it's still in my cloud environment. I just orchestrate different virtual machines now. So it's just a lot better, a lot more flexible, right? Faster way to offer services. And then this network function virtualization in SDN, we talked a little bit about SDN last week. We'll talk a little bit more about it in this chapter, the next chapter we have. And it kind of works hand in hand, right? When you're working with an orchestration system like OpenStack, remember the customer wants what? These services? Cool. Well, now I know I need to spin up these virtual machines that require this storage, and then they need this type of network. Remember, on that underlay network, we're going to spin up virtual machines, and then we build a virtual overlay network to connect those virtual machines together. And that's where a software-defined networking or an SDN controller comes into play, okay? Because the SDN controller is what actually will build the dynamically provisioned overlay network to connect those virtual computing resources together. And we'll look at this thing called a service chain. I think it's here in the next slide, where I can dynamically spin up a virtual network function VM like a firewall to provide NATing services or whatever for this customer between their two virtual server workloads in my cloud environment. And I can dynamically, by using an SDN controller, modify the overlay network to forward all traffic between those two VMs through the virtual network function VM. And that's how I can kind of just dynamically insert things into the client's traffic flow and offer these services on the fly. Okay? And so, here's the service chain. I'm a customer. I have this type of server application running in the ginormouscloud.com data center. And, I sure want to protect that. For people accessing my resources in the cloud, I'd like a firewall, that has really good, high-quality firewalling capabilities. I also, I've actually got a bunch of servers. It's actually a web farm. It's a web application. It's running on several virtual machines, and I'd like to have some type of load balancing to spread my client session request across all of the instances of the virtual server I have running in this cloud environment. And I can dynamically spin these services up. These are virtual network functions. This virtual firewall, this virtual load balancer, I can spin those up and then configure the SDN controller to build a virtual network that connects those in a chain. So all traffic from external users flows through the firewall, and then it goes through the load balancer, which dynamically distributes it out to whichever virtual machine is performing best at this moment, right? And that's the idea, right? Isn't that cool? It's called a service chain. I like this stuff. This is neat. They're going to kind of show you how to do it. So here's virtual machine. Let me get this arrow thing going again. Oops, come here, you. Here's virtual machine A, right? That's my web server, and here's virtual machine B, which is my database server. Every web server talks to a database. It's incredible. I used to do this for a living. And you know what? I'm kind of worried about somebody compromising my web server and getting, privileged access to my database. So that's where all the goodies are, right? Everybody's credit card numbers and medical records. That's dangerous stuff right there, senor. So what I'd like to do is my cloud provider here is now offering me firewalling services and IDP services. They provide a virtual network function that can offer those services to me, and I signed up for it today. So I'm going to go to the web portal, say I want that, and then what's going to happen is the orchestrator will dynamically spin up. I think this is an automated slide. Let me give it a forward click here. That the orchestrator will spin up this virtual machine that will perform the virtual network function, and then the SDN controller, here's the service VM, right? That's going to do the firewalling and the IDPing of the traffic between the web server and the database server. And then the SDN controller will dynamically, I went too fast, I apologize, I went one click too many. And then the SDN controller will dynamically provision into the hypervisor of the host that's running these virtual machines the overlay tunnels to get this traffic flowing through the new service virtual network function that I want to start using. And it's done on the fly. We don't have to reroute cables through an appliance, configure isolated. It's done automatically, right, in this fashion. So that's what we're talking about with kind of a service chain and putting these virtual network functions into use in the cloud network. Okay, kind of cool stuff there. Some examples of virtual network functions. I mean, just think about how things used to have to be. Here's my, whoops, I lost my arrow. I apologize. Let me get my arrow back. You know, here's how the traditional application infrastructure was. Here's my web server. It's plugged into a switch that routes all traffic through a physical appliance firewall that goes over to another VLAN where my database is. You know, traffic would have to go in this north-south direction. What you've got to understand is now my web server and my database are two virtual machines that are running on the same physical host, maybe. And the traffic's never going to actually leave the host. How am I going to route it through a firewall? Well, if I spin up a virtual machine firewall and configure the SDN controller to dynamically provision the overlay network to connect it in this fashion, I can insert a firewall in that traffic and offer these services in my cloud that I couldn't before. Right? And so that's why we can, this is virtual network functionalization right here, right? The virtual network function is this firewall and all of the features it supports. That's what I can sell. Okay? You know, we mentioned last week, I'm just going to hit it again here kind of quickly. We mentioned last week the virtual SRX firewall. This is, you know, a fully featured SRX firewall. This is what this is all about, right? The software that ran on our physical SRX appliance. We've decoupled the software and all the software functionality and ported it over to a VM, a virtual machine environment. It's called VSRX. Look, all of the same features. I'm a cloud service provider. I want to sell this stuff. Right? I want to sell the routing features. I can do route reflection here, BGP, OSPF, ISIS, you know, intrusion detection, antivirus, anti-firewall, NAT, VPN. I can sell this. Right? That's the idea, you know, for this platform. Use this as the firewall for your customer's cloud environment. Here's the architecture again. It's a virtual machine. Here's my underlay network. Right, that we've always have. We're running, I don't know, KVM as our hypervisor. And here's my virtual SRX, virtual machine. You know, here's my Linux guest OS. And here's the forwarding plane. The actual control plane is actually a nested VM inside of a KVM nested hypervisor, right, running on this VM. Right, so here's the architecture for that. I'm going to hit it light. We hit it last week, right? So just for time's sake, I'm going to kind of keep moving forward. I end up talking too much sometimes. And here's, you know, like we were saying, in kind of our previous example that we saw, you know, here's the virtual machines that need to communicate with some other virtual machines in another network, and I can insert a virtual SRX, and all of these virtual network functions, firewall, NAT, IDP, any feature available in a physical SRX is available in this virtual machine version of the SRX, and I can dynamically instantiate this in an automated fashion in my cloud environment using my orchestration system that we'll talk about in the next module. Okay? It's kind of cool, right? So we've already, virtual network function, it's here, right? Here's an example of it. So, and you know, another example, here's, you know, I've got, you know, these different customers. This is what I do for a living, right? You know, I sign up customers. This is how I make my money. And I have applications that I sell to them in our cloud data center. Or I host their applications for them. They spin them up. Their virtual machines are hosted in my cloud data center, and this is kind of a private cloud environment. They don't want to access over. They want to access over an IPsec connection. So to do that, well, I have a virtual SRX here that can be used to build a tunnel back to the customer's site, where they have an x86 appliance running a virtual SRX or maybe a physical SRX appliance, and we'll build IPsec tunnels to secure data in transit to and from the cloud, and also protect access to the customer's virtual machines. So there's a lot of use cases. There's a lot of network functions that these virtual SRX devices can perform, right? The same things our physical appliances can do. So there's a lot of use cases. Customers use them in a lot of different situations. But again, there's nothing different in functionality, and I can spin this up dynamically in a cloud environment, right? You know, here's another use case for this. You know, my subscribers, they sign up for internet access and WAN access, and then all their internet traffic that comes in from my customers, I configure it to be dynamically routed through VSRX instances that are running in my service provider data center. And so this is how I firewall their traffic, IDP their traffic, NAT it, whatever functions I'm offering to my customers. And so again, remember the SDN component can dynamically provision the tunnels, the overlay tunnels necessary to route the traffic through those VSRX instances in my cloud data center, right? So it's kind of cool, kind of cool. You could probably, over a couple of beers, figure out a lot of different ways that you could use this, right? It's a cloud, right? It's all possible, okay? We mentioned also last week, I'm not going to spend too much time on this one. We also, MX has been our biggest selling router in the history of our company. These are the highest performing, most capable service provider edge routers in the world. And we've taken all of the functionality of those routers and ported it into a virtual machine environment. Identical feature capabilities, identical feature sets, complete feature parity between our virtual MX and our physical MX platform. And again, from the Department of Redundancy department, I can spin this up in a cloud environment and offer routing services to my customers, right? Think of all of the edge router services that are performed, and I can sell these to my customers spun up in an on-demand, orchestrated, automated fashion because it's a virtual machine in my cloud, right? Think how fast we can do this, and think of all of the use cases that my sales team is going to come up with for these features. So just a quick thing on the architecture. Again, we have our, still have our underlay network here. Nothing's changed. Here's our hypervisor, KVM or ESXi hypervisor. And it's, the virtual MX itself is actually two VMs. There's one virtual machine for the control plane. There's another virtual machine for the forwarding plane. And it's very similar architecture to what you see in the physical MX. A separate control plane, separate forwarding plane, connected over an internal link. But any feature that a physical MX offers, I can offer in this virtual environment spun up on demand in a cloud, right? And configure my SDN controller to tunnel my users' traffic through that, so these services can be sold. Great stuff, right? So, here's a use case for it. I have virtual MX services that are kind of isolating different tenants that are running in my cloud environment, right? So different on the VMX, you can create these things called routing and forwarding instances, kind of basically virtual routers, and I can spin up thousands of these routing instances on a single VMX. And so each customer gets their own virtual router with their own routing protocols. It's completely isolated from customer B, and I can just spawn this stuff on demand. So incredibly scalable, sellable, dynamically provisionable routing services, right? We actually have an instance of VMX that's actually tuned. It doesn't have a forwarding plane component. It just has a control plane, and its dedicated network function is to be a route reflector. In large BGP environments, large service provider networks where there's hundreds of thousands of BGP routes flying around, they have dedicated platforms that just handle route redistribution called route reflectors. And so it's a very common use case for the virtual MX platform, right? And again, you're so creative, you're going to think of a lot more, right? A lot more use cases. So we're done with this content, right? So the whole goal here was to discuss what is network function virtualization. And we said it was the decoupling of the network functions from the actual appliances they traditionally run on. And we're going to port that software so it can run on standard x86 hardware in a virtual machine environment, right? And so, and we talked about the European Telecommunication Standard Institute, which is the group that kind of is helping to develop the framework for how we can move from how it's traditionally been done to the way it's going to be done now in a cloud environment. So, and we looked at VSRX, VMX, right? A lot of questions, right? Remember, we have Mark here, the smartest human being on the planet when it's related to cloud stuff and how our customers use these technologies. I'd be all over that chat window asking some really, really good questions, taking advantage of his knowledge, okay? All right. I hope I said this. Thanks for coming back. It's great to be back. Great to have you back. Great to be here. Great to learn about cloud. That's Module 5. Let's go take a look at our next module, Module 6, right? And this is going to talk really about two main components. We're going to talk about orchestration. We're going to talk about a platform called OpenStack, and we're also going to talk about software-defined networking. So orchestration and automation is a focus here in a cloud environment. And so different tools. We're going to talk about the difference between what is the role of an orchestration platform, an OpenStack, and what is the role of a software-defined networking or SDN controller, all right, in a cloud environment. So we're going to kind of figure out different parts, different levels. So we'll start with managing a cloud infrastructure. That's our first, thing that's that we're going to, kind of discuss here. And so what we're going to look at in the next kind of few slides here is there's kind of a stack. We talked about, well, no, I'm thinking of something different. I'm sorry, everybody, I do these events quite frequently, and I get them confused, but everybody here probably has heard of something called the OSI model, right, where there's different layers in the networking stack, and each layer performs a particular function. And you're going to kind of see the same thing in cloud environments, that there's different levels. There's in a cloud infrastructure, and there's different components responsible for managing these different levels. I'll start first with just looking at remember our good friend, the underlay network, right? I mean, there's literally actually has to be some physical components in my network. I need the physical servers that I'm going to run my virtual machines on. I need my storage so they can store their data. I need the physical network, the switches and the routers that can physically connect the underlay network, right? All this stuff together. And that underlay network, a lot of times, is managed through individual components. I console into that router right there or that switch, and I manually, enter CLI commands to build the underlay network. Now, remember, that's something you only do kind of once, right? Once you get that, that's like doing the dirt work, right? And now that's done, I can build everything else on top of that. And a lot of vendors, to manage those underlay network components, they have some type of software that can help this scale a little better. Juniper, we have Network Director or Security Director that can be used to manage a range of switches or a range of SRX firewalls, right? And so I don't have to get down to the individual device level, right? But once I get my underlay network done, then there are other components that are used to build my virtual network on top of that. Remember the virtual networks we use to connect the virtual machines that we dynamically spin up on this underlay network, right? And this is where SDN, or software-defined networking, comes into play. We're going to talk about Contrail and what role Contrail plays in building these dynamic tunnels, these overlay networks that connect the virtual machines together that are running in your cloud. And then above that, there's orchestration software, something like an OpenStack. This is where OpenStack comes into play. And this is the component responsible for spinning up the actual virtual machines and assigning them to hosts and asking the software-defined networking controller like Contrail and giving them information saying, hey, here are the virtual machines that I spun up for this customer. Here's the actual hosts that they run on. Will you please build the dynamic overlay tunnels, the VXLAN tunnels that connect these virtual machines together so the customer's application works, right? And then, you'll have another layer. This is where the operational support and business support systems work. This is where that portal is that the customer goes to. It says, oh, wow, these are the services I want out of this cloud. I need these virtual machines with these type of virtual network functions available to me. Thank you. And it just goes down the stack to spin up the virtual machines, configure them with the network, and that gets pushed down to the underlay network, right? And that's kind of the, kind of an orchestration stack here. For all of the levels of the cloud environment that you built, right? And so again, here's my underlay network, right? And think of how we manage that. But again, that's something you don't change once you get it built, generally, right? That's stuff customers never see. Stores no tenant information. It's just an underlay network like we've always built, right? That's the good stuff, right? And then here's where SDN comes into play. Right, to build the overlay network on top of that underlay network, and our orchestration system is what spins up the virtual machines and requests the SDN controller then connect them together with the virtual overlay network. Right, and thank you, Fred, for requesting these services from the SuperCloud portal. Okay. Right, we're going to talk in our next chapter about an application called AppFormix, and one of the things that it does is it monitors your cloud environments. How are these resources performing? How's the power supply, and what's the temperature of this, and which resources are being used efficiently or inefficiently. And it can dynamically work with an orchestration system. So this Formix application would be at this layer, the business layer of the orchestration, cloud orchestration stack. And based on its monitoring of your cloud environment, it could signal down to the orchestrator that, you know what, can you move some of these virtual machines from that host? Every time I've seen these types of alerts coming from a host, they fail in pretty quick order. And so, you know, it may not be just a customer portal. It may be some monitoring software running in your cloud environment that can dynamically change how resources are used in your cloud. So there's some pretty cool stuff being done in these environments, right? And then so, I forgot what I'm trying to say here. I think this is an automated slide and it will help me, right? Okay, so remember, we have our underlay network, our compute, our storage, our network, and all this stuff is cabled together, and the orchestration system is what will actually spin up the virtual machines, assign them to a physical, you know, compute resource, you know, attach it to some storage, and here's the underlay network where we can dynamically provision overlay tunnels to connect all these resources together, right? A virtual private cloud. Okay, now let's talk about some software that does this. Let's talk about some software called OpenStack. All right, and this is our orchestration platform. And what OpenStack is open source software that runs on a Linux server, right? You can install it in a virtual machine if you'd like. And it's a series of components, and we're going to look at these components over the next couple of slides. But the goal of OpenStack, the big picture thing it does, is it can orchestrate or automate the dynamic instantiation of virtual machines in a cloud. So this is what assigns virtual machines to physical hosts in your underlay network, right? And can dynamically spin them up. The customer wants this, great. Hey, here's the virtual machine images I want. Let's deploy those out to these physical hosts and spin them up, and then can signal down to your SDN controller to build a tunnel to connect these things together. This is what OpenStack does, right? And so let's look at some of these components over the next couple of slides. So when I install the OpenStack software, you know, here's an example of some of the components that are included. One of the components, they call them projects, is the Nova component. And this is what dynamically spins up when the customer says we want this. Okay, cool. The Nova component of OpenStack is what actually begins the process of spinning up whatever virtual machines the client needs. There's another component called the Neutron component. This is what is going to communicate the need. There's these virtual machines that are spun up on these physical hosts in my cloud environment. So the Neutron component can describe that situation to your SDN controller, which is something that we'll talk about in a minute called Contrail, that says, please build a tunnel to connect these virtual resources on these physical hosts together, right? So this is what builds the virtual overlay network, okay? There's components that handle storage, object-based storage. There's a component called Heat that actually allows you to build templates inside of OpenStack, so where you can offer service chains to your customers. Hey, here's you need a Linux virtual server, a couple of load balancers, and a firewall. It's basically a package or a template that a client can select, and that template will tell OpenStack what components, what virtual machines need to be spun up, and how to network them together, right? So there's more components. There's the Glance. This is the component that's responsible for actually storing the virtual machines. Right, the virtual machine images that can be passed to the Nova Compute component inside of OpenStack and be pushed down to a physical host in your cloud environment. There's a component called Keystone that handles authenticating administrators of OpenStack and making sure all actions are authenticated. There's a component called Cinder that can provide block storage, like file storage to customers. Spin up storage. We want storage, right? You want block storage, or do you want object storage? Okay, so. And there's also a telemetry component that can analyze how these virtual resources in a cloud environment are functioning, right? Maintain data about this, monitoring, alarms, right? Stats. So these are there's more projects, there's more components in OpenStack, but these are kind of some of the common ones that are used, right? And so let's look at this a little bit, how this works. how these pieces work together. So up here at the top, again, here's my OpenStack. And one of the components inside of OpenStack is the Nova component. So, oh, wait a minute, you wanted some virtual machines? Oh, okay, cool, and those virtual machines need some storage. So I can spin up and assign whatever virtual machines the customer wants to physical host in my underlay network, right? I can use the sender to create dynamically some storage and assign that to the virtual machines. And there's the neutron component inside of OpenStack that says, okay, I have these virtual machines on these hosts, and so I need them connected in this fashion. That neutron component can pass that information down to a software-defined networking, or SDN controller. And in the cloud world, the most popular type of SDN controller is an application called Contrail, right? And Contrail can intercept what the neutron component in OpenStack requires and translate that into something that the actual virtual router can understand and dynamically build overlay tunnels. The idea, the purpose of the Contrail, what Contrail does, the SDN controller Contrail does, is it's an application, and it can dynamically provision a Contrail virtual routing agent to each physical host in your underlay network that's going to host virtual machine workloads for your customers. And that Contrail virtual router can dynamically be programmed by the Contrail SDN controller. Remember, the whole goal of SDN is to centralize the control plane, separate the control plane from the forwarding plane, right? And that's what we're doing with this SDN controller, the Contrail SDN controller, right? So they work together. The orchestration, OpenStack, I need this compute, I need this storage, I need this network, and the SDN can take those network needs and dynamically build the overlay tunnels. That's what it does. That's what Contrail does. That's where it fits kind of in this orchestration stack. That's its job. All right? And so here's kind of the big picture. I don't know if this is the interface a customer would use, but the web UI object in OpenStack or project in OpenStack is called Horizon. So I open up a web browser, I go to www. whatever the IP address of my OpenStack server is, and this Horizon component lets me log in, and it allows me to say, I want to spin up these virtual machines. And that information is passed, remember. Oops, I lost my arrow. I apologize. I'm not very good with this arrow. So the Horizon takes what I want and sends it down to the Nova Compute component that says, okay, I want to spin up these virtual machines. I want to assign them to this physical compute node, right? And then I will also tell the neutron component that here's the virtual machines, here's the host that they're running on, build a network between them. And the neutron plugin says that to my Contrail SDN controller, which can then translate that into networking commands that the actual Contrail virtual router agent can understand and dynamically provision, for example, the VXLAN overlay tunnels that connect these customer virtual machines together and isolate them so they can communicate amongst themselves. And that's the whole way, that's the big picture here, right? How I can orchestrate the dynamic instantiation of the compute and storage resources and use the Contrail SDN controller to dynamically provision the overlay tunnels to connect them together. That's what we're trying to do here, right? This is cool stuff. I like this. Okay. I just saw that. Hey, I saw something where I thought I saw something in a meeting the other day where that CSRX I thought was the first half of this year, but who knows, right? So let's talk about NSX, right? Now, this OpenStack and this Contrail SDN controller, these were designed to work, these are open source components designed to work with open source hypervisors, things like KVM, right? But in the virtualization world for a long time, there's been a company called VMware. And they really kind of were the 800-pound gorilla when it comes to instantiating virtual servers. They have their own software, they have their own proprietary type of hypervisor. And so how does that proprietary software work in an OpenStack, Contrail type of environment? And really what they do is to allow them to kind of use their components in an OpenStack orchestration environment is they simply take advantage of APIs. right? The SDN controller, the Contrail SDN controller, in a VM world is a component called NSX. So it's simply through APIs, just like the Contrail SDN controller does, intercept, I need these networks that are built to connect these virtual machines. The VMware NSX component can actually take those commands and translate them into something that their vSwitches understand to build the overlay tunnels that connect these virtual resources together. So just over the next couple of slides, I'm just going to kind of flip through these to just simply take advantage of APIs. That's what you use when you're application programming interfaces. That's how you get software to talk to different versions of software. You get them kind of speaking a common language. And that's what application programming interfaces do. So it allows you to kind of migrate things over time a little bit. We can get some of this open stack going, and we can still use some of our pre-existing VMware components, right? We can get them to interoperate together, okay? So that's still available as an option to you if you're working in that environment. So here's the example. I need these virtual machines spun up, and the Neutron API can pass these commands to the VMware NSX plugin that can forward them to the NSX controller, and the NSX controller can then speak its language to build the virtual tunnels to connect the virtual resources. And that's all I've got to say about that, right? So you can kind of have a little bit of a hybrid there. So a couple of things here, right? We talked about kind of an orchestration stack, the different levels. We looked at kind of the underlay network, the different layers of a cloud, overlay network, and we talked about two main components that can make this work in an automated fashion. You still have to build your underlay network, but remember that's something you do kind of once, and everything else is dynamically provisioned on top of that, and we do that using software like OpenStack. That is the orchestrator that will dynamically spin up the compute, the storage, the network, and cloud environments that your users request. And then we use, when I say I have these virtual machines running on these hosts, how do I connect them together? That's where the SDN controller comes in, and it installs a routing agent on all of the physical hosts in your underlay network, and can dynamically provision those virtual overlay networks onto those virtual routing agents. And that's your overlay network. And so that's how it gets spun up. That's how the network compute and storage is dynamically spun up using an orchestration system like OpenStack and an SDN controller, like Contrail. Right? That's that chapter. Mark is doing a wonderful job answering these questions. I sure thought we'd get a lot more questions about all these complex parts here. I must be doing an incredible job of explaining these. No questions at all about orchestration and automation. I had to read this stuff 15 times before I finally sunk in. Man, you guys are smart. Wow. Okay. All right. Okay, Alan, that's fine. Remember, that's what we have, a forum, right? We have an open learning forum. You can post them in there, right? So that's the cool thing about this, right? You can read this over and over and over and over. And man, I like to do that because sometimes I have to hear it a couple times. And I also remember our software documentation can kind of get you going as far as getting additional examples, use cases, case studies. Again, I have to hear things 2 or 3 times for 2 or 3 different people, and it'll finally sink in someday. So here's our last one. Our last chapter is about an application that is designed to work in cloud environments called AppFormix. So we're going to learn a little bit about that, and I'll try to focus on the things I think you're going to need to know from a high level to be able to answer some AppFormix questions on your JNCIA Cloud Certification exam. So what does AppFormix do in my cloud network? What are the different components, and then what do they do for me? What do I get out of this AppFormix application in my cloud? So we start off by looking kind of how services are born and managed in a network, a data center environment, right? So some customers who come to you, they could be an internal customer, the accounting department has an application, and we need these types of resources to. And so we're going to have to we need to design this, right? So once I gather requirements, we can kind of do a design, and if that passes muster, we can kind of try to build it, implement that, and then we can verify with the customer, does this meet your needs? And then from that point on, we're kind of in maintenance mode here, right? The application's working, they're happy, right? And then, of course, we want to be agile, and we like this to all be software defined and as automated as possible, right? That's all good stuff. And so we want to be able to do this in a faster, more agile fashion, right? That's what we want to do. We want to run this in a cloud environment so we can spin these up for these customers. So now these resources, these applications are running in my cloud. My cloud. I built that. These folks are using my resources. And maybe that new accounting application, my heavens, that's an awful chatty application. Those virtual machines are running on a shared host with other customers' virtual machines, and I think that the accounting virtual machine is dominating the resources of the shared host and affecting the performance of virtual machine 2 and 3. Do I have the type of visibility to determine what's going on here? Can I monitor resource utilization at the actual virtual resource, virtual machine, virtual network function level, right? So I can identify and then bill and charge people for how they're actually using my underlay network resources, right? That's what I'm trying to do. And so, software, we've talked a little bit about Contrail. This is the software that Juniper Networks provides and our customers use in their cloud environments, right? We talked about Contrail, our software-defined networking controller, to dynamically build these overlay networks that connect, my virtual SRXs and virtual MXs together, right, in my service chain. What we're going to focus on in this module is what AppFormix can then do in my cloud as far as monitoring how my resources are being used, right? How is my underlay network being used? So I'm trying to think of how to say this to you. AppFormix is software. We're going to see in a couple of slides. It's kind of a three-legged horse. There's an AppFormix kind of application, kind of like a controller, right? And then there's an AppFormix agent that gets installed into the physical hosts that make up your underlay network. The physical servers are going to run the actual client virtual workloads. There's an AppFormix agent that gets installed on there, and it'll install on any flavor of Linux. Red Hat, CentOS, Ubuntu, whatever you're running on your, whatever your KVM hypervisor is running, whatever flavor of Linux it's running on it, and I can install this AppFormix, and it can monitor any application. Slide is on the intent-driven operations slide still. Uh-oh. Are my slides not working here? My slide's not moving, folks. I'm actually moving through slides, and nobody's seeing this move. Slide 6 now. I'm trying to be on slide 7. Hey, okay. How about, has everybody seen me on slide 7? Sometimes in Adobe Connect you get a little bit of lag, and so, okay, cool. Hey, everybody, thank you so much, right? Because thanks so much for keeping your eyes open. I promise I'm not crazy. I'm actually talking about slide 7, okay? And so, yes, siete. Thank you, Chris. So, yeah, and I can monitor any application running in your cloud, any virtual machine. Let me go forward here and show you a little bit more, right? And so, when your customers, let me think of how to say this to you. When your customers spin up, hey, I would like to sign up for your cloud services. I would like to run my applications in your cloud. You're going to have to give them some type of service level agreement, right? I guarantee you this level of availability, these levels of performance, right? And this, and I'm going to have to monitor that. How do I guarantee my customers are getting these levels of service? Well, I've got to monitor this stuff. I need detailed statistics about, how much CPU utilization is this particular virtual workload using, how much RAM, how much of my storage, how much of my data throughput is being utilized by every single virtual resource that's running in my cloud data center, right? So then I can analyze that data, perform some types of machine learning across all of this data, and actually be able to make my cloud very dynamic and modifiable on the fly based on how my actual resources resources are performing. And we're going to see instances of this going forward. All right, I'm on slide 9 now. I hope everybody sees that. So, hey, this thrown in here, right? So, let me think of how to say this. You know, I guess I can use this analogy that just take a regular car, right? And you just bought this new car, and it comes from the factory configured a certain way. But you, being the technical mechanical wizard that you are able to kind of tune that car to where it performs a little better than it did when it drove off the lot, right? You change the way the air intake works, and you know you add in some new features that increase the amount of horsepower in it. It runs better. I change the suspension so it rides, but you can do all kinds of things. You can do the same thing with the hardware in your cloud environment. And you need to analyze how the applications, how your customer workloads can benefit from you actually tuning that hardware to make their applications run better. An example here is a lot of Intel processor platforms support something called cache allocation technology. And it kind of can allow applications to use cache resources very close to where the CPU is located on a platform. And so they can access data in cache quickly, as opposed to having to access data that's stored in RAM, right? So it's maybe I have some type of energy trading or stock trading application that can really benefit from that, and I can offer a better service level to my customers because I bought the right hardware for their cloud applications to run on. And there's all kinds of knobs I can tune, even down at the hardware, the physical underlay network label, that allow me to differentiate my service levels and sign up more customers and offer better services and make more money and all that fun stuff, right? So take advantage of any little knobs you can tune in your cloud environment, no matter how small or they may seem, right? And then try to spin up your cloud environment applications that take advantage of the hardware that actually has these features. Okay. So let's look at AppFormix. Let's get back to AppFormix here real quick. Again, I mentioned earlier it's kind of a three-legged horse. There's the actual AppFormix controller. That's the application that's going to do all this, kind of data gathering. And there's an AppFormix agent that gets deployed down on your hosts that are running the actual, the underlay network that are running your client's virtual machines. There's an AppFormix agent that's installed on those. And this AppFormix agent, again, can do detailed, dynamic gathering of information about all of the resources that each of the virtual workloads is using and streams that data back to the AppFormix controller, and you can view it through a web dashboard. You open up on your management station, www.appformix. Whatever it is, and here's my dashboard. And again, we're going to look at a few screens here going forward where you can see the individual workloads, how they're performing, what's their resource usage levels, and you can do a lot more with it than that. But that's kind of the basics of it. So an agent that's installed on my host that monitors the virtual workloads down to an incredibly fine, detailed level and can feed that information back to a controller. And that controller actually has some machine learning algorithms that can analyze the data about the resources, alerts, alarms, data, resource utilization about your cloud environment. And the cool thing is you're going to see, let me see if it's the next slide. I'm going to slide, come here you. I'm trying to go to slide 12. I click to go forward. Oh, it's an automated slide. I'm looking down and I'm not looking up. So they talk back and forth. Okay, I'm sorry. I'm kind of nervous about my slides not working. I'm not paying attention to my screen anymore. Yay! Here we go. So here's a little more detail. I'm on slide 12 now, right? So again, I've got this AppFormix agent. It's deployed out on my host. It's monitoring all these. Here's how many CPU. Here's the temperature of this host. Here's any kind of alarms, alerts. Here's the status in this spread. This agents are on all of my cloud components in my data center, all of my virtual hosts, my physical hosts in my data center. And that information, again, is streamed back to the AppFormix controller. And on that AppFormix controller are actual adapters that can speak to orchestration systems like OpenStack, or if you're spinning up instead of virtual machines containers, there's a Kubernetes adapter in here. And so the data streams back to the AppFormix controller. It analyzes it, stores it, and runs machine learning algorithms on that. And that sounds really fancy and complicated, but really what that means is it can kind of learn things. And you build policies, for thresholds, for example, that says, if you start seeing these types of events, then I want these actual functions to be performed. So back to the machine learning aspect, once I've seen, for example, on a physical host that, man, I'll tell you what, every time I get this alert from a physical host, like a temperature alarm, usually within about an hour, that physical host fails. And all of the virtual workloads that were running on that physical host are now dead. I'm not meeting my customer service level agreements very well if this keeps happening. But what AppFormix can do, since it receives, it's a central gathering point for all this type of information about how your cloud environment is functioning, it can use these machine learning algorithms and begin to predict things. Like, uh-oh, there's that high temp error again. It's on a different host this time. I just know about I've seen this movie before. I know what's going to happen. So I can dynamically call out, to example, OpenStack using my OpenStack adapter and say, can you please move these virtual workloads from that host and put them on a different host in the data center? And oh, by the way, tell the SDN controller to modify the overlay network so these components are realigned and keep functioning, because I know the host they're running on right now is about to die. So when we talked earlier about these operational support systems and business support systems that can dynamically call out to the orchestration stack and spin things up, move things around, AppFormix is an example of an application that can do that with these adapters, right? And so your network kind of becomes a living, breathing thing. I'm monitoring everything. I've got my finger on the pulse of everything, and I can kind of see when things are going south. I can predict things and dynamically take action. So kind of cool. Kind of neat how that does that. And we're back to the web dashboard now that you'd see inside of AppFormix, and so you can get basically a snapshot of, hey, how is my cloud performing right now? But since it's gathering the statistics that it has over time, I can get kind of a historical view of how was our cloud performing last quarter, how are our resources being used, what types of virtual machines were spun up, how much storage is being, which were most popular. So I get detailed statistical analysis of how my cloud is performing now, how it has in the past, and I can use that information to kind of forecast how my cloud may be performing down the line, so I can do resource optimization. Maybe I've got to put a crowbar in the wallet and do some CapEx here to upgrade some components. So you assign costs. What you'll do is you'll define projects. So here comes our good friend, the accounting folks again, and they want to run these applications. So these application has these virtual machines, these network resources, and I define that all in a project. And I can assign costs to that project. And then I can bill these different departments monthly, for example. Hey, look, your application has used this much of my resources, and this is how much you have to pay for that. So this can be in a public or a private cloud environment, right? Here's an example of the screen. Hey, you use these virtual machines, you use these licenses, here's the cost for this, and here's a bill. I think the actual next screen, here's your bill, accounting. Oh, I'd love to get $10,000 from those guys over in accounting. They're always sweating me for money. It's good to get some of theirs back, right? And so this is another thing that AppFormix can do. On top of notifying you, here's the state of your cloud, how the resources are being used, I can assign costs to that resource use and then bill the different customers in my cloud environment. Right? And stats, oh my heavens, the actual physical host CPU usage, how much of that physical CPU is being used by these virtual machines, disk usage, memory usage, storage usage, right? I/O usage, network usage. I can track every last lick of this with AppFormix. And again, use that to forecast, use that to build, use that to dynamically move resources around in my cloud. There's a lot of uses for AppFormix, right? Here's some statistics about, an individual host, again, CPU usage, memory usage, all this type of stuff I can read in real time about any host in my cloud environment. All the hosts in my cloud environment. So detailed visibility, right? Heat maps. Let me show you the next screen because it'll give you an example of a heat map. That's one of the functions inside the web UI is, the little squares represent the little virtual resources that are running kind of in my compute cloud storage environment, right? Or my cloud environment, excuse me. And, you know, generally green, good, red, bad, yellow, it's not so good. You know, so these individual components are assigned a color. You can kind of mouse over them, get detailed information about, you know, hey, there's an alarm here, right? So again, real-time information about how the individual components in my cloud are functioning. Okay. So, and then again, notifications and alarms, right? I'm gathering all these stats, that agent's sending it back to AppFormix. I can post these alarms to external systems, or I can also write policies that based on these different alarms, I can actually remember I have an OpenStack adapter, I have a Kubernetes adapter, so based on these alarms, I can write policies that tell AppFormix to use these components to dynamically spawn or move resources around in my cloud dynamically. I have service level agreements, and if I don't meet them, I have to give my customers money back, and that makes me sad. Right? So it's a living, breathing cloud network with this, right? You know, I can alert administrators with these alarms, but again, one of the things I think about is implement automated remediation steps, right? I can integrate with my orchestration software and move resources around dynamically, right? So that's kind of cool stuff. I like this AppFormix, right? If I have a cloud, I might need this, right? And there's a type of service that is common in cloud environments. It's a distributed storage system called Ceph. They want you to know that if you're using that in your cloud environment, there's actual special component inside of AppFormix that has measurement metrics just to let you know how this type of storage is performing, right? So I get detailed statistics about my storage. In your orchestration environment, your OpenStack requires a MySQL database. I might want to see how that's performing, and if I'm also selling MySQL database services to my cloud customers. I have virtual machines that have MySQL already up and running. What do you need? I can monitor that. There's dedicated components inside of AppFormix to monitor MySQL databases. And the OpenStack components, the Neutron plugins, the Nova plugins, when they communicate out to their agents on these actual underlay network components, there's a protocol where there's an application called Rabbit Message Queue that's used to, I can monitor that. If my orchestration can't contact, my OpenStack can't communicate with the agents on the actual host on the underlay network, or my SDN controller can't communicate with the virtual router that's been embedded into the hypervisor, we can't build the over. I need to monitor that stuff. Can those components communicate? If not, we can't dynamically bring up resources in our cloud. So it's extensive visibility and monitoring into how are the resources in your cloud network being used, right? And so I can monitor all of your OpenStack services. We mentioned the Ceph, the RabbitMQ, the MySQL. I can monitor all of these components that are used in your cloud environment, right? And that's the idea. And extensive reporting, since I'm gathering this data, let me show you in the next couple of next slide here. Here's an example of a report. I can get these reports in HTML format, PDF format, XML format, CSV format. I can get these reports and export this data in different formats to export in external reporting systems if I want to, say, archive this data over longer periods of time or chomp on it with different algorithms, right? So since I'm gathering all this data, I can view it. Again, more detailed information about how my cloud network functions. This is good. I need this, right? I need this. Somebody's going to call and ask me one day, and I can't go, well, I don't know. Right? So to summarize AppFormix, right? And again, when I'm dealing with AppFormix here, I don't need you to have a neck-deep level of understanding about how to install it, configure it, what every screen does, and what every option is. I need you to know that AppFormix is software that is designed for cloud environments. There is an AppFormix controller, and there is an AppFormix agent that's installed on all of my physical servers on my underlay that make up my underlay network. And that agent can monitor all of the virtual resources that are dynamically spawned up by your, for example, OpenStack, right? And your SDN, I can monitor every individual, down to the virtual resource, the virtual machine level for client A. All the memory, all the CPU, all the I/O, I can monitor all that. I can assign a cost to that. I can bill the customers for that. I need to do that somehow, right? And again, since all that information is being fed back to that app performance controller, you can write policies that define if certain thresholds are crossed, if certain events or alerts happen in my cloud network, that I can configure the app performance controller to dynamically signal to OpenStack or signal to Kubernetes to move some network resources around inside my cloud. And that's all I need you to know, right? And that should cover any kind of questions you might get on your JNCI Cloud Certification exam. All right, everybody, that's all our content for this week, right? Please ask some questions in our chat window. Now, next week is our last content review session, right? And so we're going to do modules 8, 9, and 10, and that will be it. So between now and next Thursday, if you can, please get a chance to read over that material. Try to bring a bag full of questions with you next week and take advantage of having Mark here. Man, he's a well of knowledge about this stuff. He's been in the field. He's worked with our customers on this. So anything that you want to ask that you think will help you in the future, be it on your JNCI Cloud Certification exam or, hey, Gordon, we've got it. We just bought App Performance. Mark's an expert on App Performance, right? So ask questions, right? So I don't really have much else. If anybody doesn't have, any questions, I want to kind of, again, thank you so much for participating in the program. Remember to take advantage. If you have some questions between now and the next time we get together, please take advantage of the Open Learning Forum. Remember, you go to forums.juniper.net and you create yourself an account, and you forward that username to education-services@juniper.net. So you can be given permissions to access our private forum and post your questions in there and review that material. A lot of the questions that you ask have already been asked by previous attendees, right? So, and then Nathan asks, what are some first steps toward moving from the traditional network to SDN? Well, you're going to have to figure out what components that you currently have can be migrated to virtual machine environments, and you may not be able to get everything at a time. Right? You may have certain applications that, hey, we can do this today. We can get these things in a virtual machine and we can get them running in the cloud. So let's get an underlay network built, figure out what we're going to use for orchestration systems, probably OpenStack, probably Contrail. And then we can just start beginning to build a front end for this and dynamically provision the services our customers need. And then we can kind of work on what doesn't, what's not ready today. Maybe we can start trying to work to migrate this over time and come up with some type of plan to do this. So migrate what you can and work on what you can't, right? And I don't know if that's a decent answer, Nathan. Mark's probably got a really good answer. What do you think, everybody? Oh, man, Nathan, you're welcome. I hope that's a good answer. I hope it makes sense. Okay. Sometimes my answers don't do that. Oh, thanks, Don. I appreciate the kind words. All right. Are there any limitations with redundancy of systems, i.e. running high availability virtual IPs? Any limitations with redundancy of systems? Alan, I don't know if I get this. Maybe Mark does, or maybe somebody else says, hey, everybody, please feel free to answer some questions. Okay, Mark, yeah, thanks for fleshing this out a little bit. Anybody is welcome to answer a question. Please don't make up answers. The VSRX and VMX both support HA. They both have all kinds of high availability features in them, Christopher. I don't know, like with a physical SRX, I know you can cluster them together. I don't know if I can cluster a virtual SRX. Maybe Mark knows that. I try not to make up answers, Christopher, so if I don't know, let me crank up the Google machine real quick here. Let's see. VSRX cluster configuration. Yeah, it supports, who was asking that question? Yeah, you can cluster a virtual SRX, Alan. Yeah, you can cluster a virtual SRX. Virtual MXs, or MXs don't really support being clustered together like a virtual sync and state and so forth. but you have so many redundant, like graceful restart and nonstop active routing, and there's all these additional components that do provide high availability inside of Junos, right? So it depends on what you're talking about high availability wise. I get a lot more redundancy out of virtual MXs because I can spin these. If I lose one, I can spin up other instances of them. That's what you get out of the cloud anyway, right? Okay, Andrew. Hey, cool. I've done it a lot with physical SRX. I used to teach that a lot, and we have a new course that does that, but I haven't taught it since we've gone to the virtual SRX platform. Okay. Yeah, you're right, Alan. Okay, I got you. Hey, thanks, Christopher, for the link. I just found that I should have posted it too. I apologize. I just Googled it and go, yeah, it's there. Okay, thanks, Mark, for your answer. Great questions, everybody. Great, and look, I don't know all the answers, right? You guys are out in the field doing this for a living, so contribute your knowledge here. What else, everybody? Ask some more questions. Share your feelings with the group here. Okay, good deal, good deal. Yeah, VSRX is pretty cool. It's a fully functional Juniper device, and it's got security built into it. So, all right. All right. Looks like things are kind of slowing down, and I know some of you are going to start dropping off. So again, I just want to thank everybody for taking the time to be here. Please come back next Thursday and try to read, the last 3 modules, 8, 9, and 10, if you can. And bring some questions. Just thank you so much for participating. Remember the forums. And so, we're kind of running out of time here, so I'm going to kind of just wind it down. And I want to thank Mark, and I want to thank Lawrence, and I want to thank you, right, for being here. So just keep it up. You're getting there. You're eating this elephant one bite at a time. And our next session is our last one. And by the end of that, think of this now. You're going to be pretty ready to take this JNCI Cloud exam. So just great job, and thanks a lot, right? So I'll see everybody next week.